Page 520, number 42. Remember, my job is not to tell you all the answers, but to help you figure out how you can do this. So let's take a look at this one. It says, use the diagram of the quadrilateral ABCD with the auxiliary line segment drawn to write a two-column proof of theorem 8.4, which says that opposite angles are congruent. And all we're given is that ABCD is a parallelogram. Okay, so let's look at our figure a minute. When we look at our figure, we know that these are parallel, so we can go ahead and mark that. And that's one of the first things you should always do. You should be drawing your figures. If you're not drawing your figures, you're having a problem there. Okay, that's congruent. Parallel. All right, now this is a transversal. Okay, now if we want to prove that these two are congruent, remember I told you it's a good idea to use different colors. That's what we're trying to prove, and the blue is what we know. All right, so you look at that and think to yourself, well, what do you know about parallel lines? Now we can only be talking about the angles that are inside the figure, because the angles on the outside of the figure aren't going to do you any good. So using your corresponding angles aren't going to be very helpful. But the interior angles, those are really helpful, because in your parallel lines you have these, you have these interior, these interior angles that make up a part of this triangle. Okay, so if we're looking at this transversal, put it in a different color. Here's our transversal going through here. Okay, we can say that these two angles are congruent. One's on one side and one's on the other. What are those called? Alternate interiors. Now, if you've not studied Chapter 3 with us, you won't have these theorems. So if you look back in the back of your book, there is a list of theorems. That way you don't have to flip through the pages. I think it's on page 9, yes, 927. 928, these are a list of theorems. It's not a good list to use. You really need to put them on your theorem list with pictures. If you're not sure how to do that, get with me during class time or after class time at lunchtime. In the 3.1 to 3.6 section, you're going to find all of your theorems about parallel lines. And these are called alternate interior, and they are congruent. Okay, now if you're looking at the other set of parallel lines, and I will highlight them. If you're looking at the other set of parallel lines, there's another set of alternate interior angles that are congruent to each other. Okay, so now we have angle, and we have angle, and then we should know that BD is congruent to itself. So we have angle, side, angle to prove these two triangles are congruent. And since angle A and angle C are part of these two triangles, and I will highlight the two triangles. Okay, we know that corresponding parts of congruent triangles are congruent. Okay, now once we've done that, we've got our angle A and our angle C being congruent to each other. We can see that angle B, what they're calling angle B, they're talking about CABC, the outside, okay? And for angle D, you know, I tell you, you're not allowed to do that. And this is exactly why, because it's confusing. Okay, angle D is really angle ADC. So even though they've written it, I mean, they're telling you to prove the theorem, but they've written it just as though you were proving that theorem. That's what the theorem says, is that opposite angles are congruent. But they put this transversal in the center of it, and that's where the problem came in. Okay, so once we've done that, we can add up these two angles together. Since they're congruent to each other by substitution, when you add these two, that's the same thing as adding these two, because they're congruent. All right, I'm going to erase everything off the figure, and now we'll write the proof, and I'll remind you of some of the things that we've said so that you can get the proof written. Okay, so in order to make this fit, we're going to have to blow it up. Okay, here's our statements. Statements and reasons. Okay, first of all, you know that every proof starts with the given. So you're going to write in the given, and you need to copy this down. I'm expecting you to copy down the given statement and what you're supposed to prove from the very beginning. You need to draw the figure, and I should see colors on the figure probably. You certainly need to be marking things like the fact that they're parallel. So you're going to go up here and mark that they're parallel. And you have to write on the figure. You cannot tell me that you've made a serious attempt to do a proof unless I see some marking on that proof. So you've written the given part. I'm not going to write it, not because I'm lazy, but because you need to do that for yourself. Okay, now that you've said that they're parallel, it's a parallelogram, then you will go on to say, well, what exactly does that mean? What does it tell us that we need to know in order to prove these two triangles are congruent? We know that we have some lines that are parallel. So you're going to write those down. And you're going to use some symbols. You're going to say this is parallel to this, and this is parallel to this. And how do you know? Well, it's called a parallelogram. That's the definition of a parallelogram. Okay, and you've already written that BD is a transversal. Is that part of your given statement? No, it's not, so we need to write that in too. Number 3 should be that BD is a transversal, because we haven't mentioned that, and that's by the definition of a transversal. That's what we call them. Okay. Then number 4. Okay, looking at this transversal, since I know there are students that are going to be working with me that were not here for chapter 3, I'm going to need to go through some of this. Looking at this transversal, we see alternate interior angles. Interior means they're inside the parallel line. Alternate means there's one on one side of the transversal and one on the other. So now we're going to name these angles. So you're going to write angle, whatever, is congruent to angle, whatever. You're going to name it. Okay, and in the same statement area, and you can pause this if you need to, so you can write it down. Looking the other direction, you have another set of parallel lines. So you have another set of interior angles right here. And you're going to name those angles. 3 letters to name those angles. Angle what is congruent to angle what. And you're looking in that section 3 if you don't have it on your theorem list. If you don't, you need to put it on your theorem list. And what was that theorem that we said? If lines are parallel, then alternate interior angles will be congruent. And you can use symbols. Okay, now to prove angle A and angle C, we need to prove the 2 triangles are congruent. So we have this segment right here, and what do we know about it? It's congruent to itself. I really should be using my blue. Okay, and that's BD is congruent to BD. And how do you know that? Okay, this is another one of those that should be on. Actually, I think most of you know this by now. Reflexive property, that's a property. Okay. Now we have triangles that are congruent, and you're going to say triangle, and you're going to put in what it's called, is congruent to the other triangle. And how do you know that? 3 letters. Tell me how you know that. Okay, now when you have triangles that are congruent to each other, what do you know about all their parts? So this is the first part of the proof that we had to do. We had to say angle A is congruent to what? Okay, it's in your proof section. And how do you know? Corresponding parts of congruent triangles are congruent. Since they're both parts of these corresponding, if they're corresponding parts of these two congruent triangles, then they have to be congruent to each other. Okay, now this is interesting because my teacher's manual at this point says, well, angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. But that can't be so because we used this angle and this angle to prove the two triangles were congruent. And we used this one and this one. Okay, now the only thing they can mean by angle B is congruent to angle D is this whole angle here and this whole angle here, and those are not corresponding parts of congruent triangles. So they're incorrect on that part, and we're going to fix that because I'm not going to let y'all get away with that. And if I had my way, I wouldn't let them get away with it either. Okay, so number 8, we're going to go back to these angles up here, and we're going to use the angle addition postulate first. We're going to say that we know that angle ABC is equal to some angles added together. Okay, the first one is angle ABD. And the second one I'm going to let you name. Okay, and then you're going to go to angle D, and you're going to tell me what that's made up of. And you can do that. Okay, and now it's wise if whatever you've written up here in this section, whatever letters, the order that you use the letters for here, should be the same in this section right here. Otherwise it gets really confusing. Alright, now in order to prove that these two are congruent to each other, since you know that this angle is congruent to one of these two angles here, depending on what order you put them in, and this angle here is congruent to one of the other one, then you can take out this one, these two, and you can put these in again. So now you're going to have number 9. We don't need to rewrite this statement because we've already said it. So we're just going to take this angle right here, we're going to put it right there, and then we're going to say is equal to angle ABD plus angle whatever you have right there. Okay, angle, let's see, oh, I forgot to write in number 7. Angle A, oh, that was 6. Okay, so I put this in the wrong spot. Sorry about that. The Kapikatuk is number 7. You were supposed to write number 6 yourself. Okay, number 8 is the angle addition postulate. All right, and number 9 is we took these out and we put these in. And what's that called? And how come we could do it? We could do it because of this right here. They're equal to each other. And so that's called substitution. All right, now then we've got this that's the same, and this that is the same, that's equal to this, and what you have right there. So 10 should be angle ABC is congruent to angle, and this is what they're calling angle D, but you go ahead and put in your letters the way you have them. Okay, and that is, you could use 2 different properties for this one. What's the one that says if A is equal to B and B is equal to C, then A is equal to C? You could use that one. That's the transitive. Or you could use substitution. You could say, well, I took out this and I put in this. Either way. Okay, so you should have that proven. Good job.